Up next, I'm joined by Hugo Latapie, Principal Engineer of Emerging Technologies and Incubation at Cisco, and Eileen Vidrine, Chief Data Officer for the U.S. Air Force. Hugo, Eileen, thanks so much for joining us today. How are you both doing?
Doing great. Thanks for having me.
Great. Thanks for including me today.
Absolutely. I'm very excited about our conversation, and I want to start with data and how it plays into the overall concept of AI. Obviously, AI is our larger theme today, but you can't do one without the other. So let's start with the data. Why is it so important to AI in the Department of Defense? Eileen, you're a CDO within the Department of Defense at the Air Force. So I'd love to start with you for that question.
Well, thanks, Billy. It really is, if we want to do AI and machine learning at the speed of relevancy, we really have to have great volumes of high quality data. And the great volumes of data, absolutely, but the quality piece is the piece that we're really trying to emphasize with our Airman and Guardian right now in our department. How do we really make sure that we get that correct? And we are really trying to use our Airman and Guardian as much as possible to be part of that great quality, high volumes of data solution moving forward. And we, like just recently, we wrapped a datathon that really focused on data prep around a specific data set so that we could really focus on the quality piece of that conversation.
That's great. Thanks for starting with that foundation. Hugo, I'd love to hear your thoughts from Cisco.
Yeah, I totally agree. The importance of data is paramount, and it's been a long time since I think maybe 10 years ago we were looking at, we didn't have the data, we didn't have the processing power, and now we have a lot of data, we have a lot of processing power. You almost could say that we have too much data, and it's quite interesting when you think about many definitions of intelligence are really even about how can you process massive amounts of information and know what to throw away. How can you deal with petabytes continually coming in? And so that's something that we're really looking into right now is to find intelligent ways to not just build up in data meshes and in data lakes, but to in real time begin to know what to keep and what to throw out, in some meaningful way. But it's an opportunity that we think is going to grow.
So one of the topics, the concepts we talked a lot about in preparing for this conversation was the idea of distributed AI and sort of all of the enabling technologies that go into that to sort of support the DoD's future vision for the battlefield, this really sensor-driven battlefield where everything's connected. Hugo, I'd like to go back to you to hear a little bit about that distributed AI concept and why that's important for the Department of Defense.
Well, I think it's important for everyone. I mean, we're doing a lot with edge computing and federated learning and all of that. And one of the fundamental issues with AI that we're seeing right now that's kind of, coming more to the forefront is the fundamental idea of what is knowledge to begin with. And so the fact that most AI doesn't really have a clear definition of what knowledge is. What does it mean to do some theoretical things like how do you define the symbol grounding? How do you do cumulative learning and that sort of thing? So actually, we're finding right now that now that we have a solid knowledge model, that we've published papers on this, and we're actually using our technology for the DoD. When you solve the knowledge definition problem that covers abstraction and symmetric and anti-symmetric relations, what you get is the ability to begin to solve the issue of federated learning, cumulative learning, and they're quite related because when you imagine you have thousands of learning elements, distributed in the network, the question is how do they build on the same knowledge base and cumulatively learn over time, over months, years, and thousands of these, and coalescing their knowledge. So we're seeing some phenomenal results now where we can begin to see this cumulative learning and federated learning work together with our knowledge model. We're really looking forward to see what we do with, we have a few projects, but it's a very exciting time to see these technologies come together.
Yeah, it's a very cool concept. And to me, it sounds a lot like what the Department of Defense is trying to do with JADC2 or Joint All-Domain Command and Control. Eileen, I know that's something you're working on quite a bit within the Air Force. Can you talk to us about that?
Well, I think that it's not just for working in my department, the Department of the Air Force. It's really holistically the Department of Defense, 3 military departments, 5 military services, really making sure that our data works not just for one department, but for the whole Department of Defense. And so in February of this year, we had a data summit that really kind of, we brought senior leaders together to make core decisions on the true data fabric moving forward. And that piece is now maturing out at each military department level to facilitate that information and data sharing, not just within your organization, but holistically within the data ecosystem.
Yeah, that's a big undertaking, but it sounds like a very important one, and we look forward to seeing what happens there. I'd like to move on to a question about the limitations of AI today, and how do we get beyond that within the Department of Defense? Eileen, how about we go back to you?
Well, one is about getting the data correct, but it's also making sure that we get the algorithms correct. So one of the pieces, the DoD, the JAIC, published an AI strategy. The Department of the Air Force has our own AI annex, but it's also making sure that we're embracing the OMB data ethics framework component, because we need to make sure that that is ethically solid. And so it's about getting the data right. It's about getting the algorithms right, but also making sure that we are vigilant about making sure that we're doing that vector check and making sure that there isn't, we're minimizing bias in any across the whole life cycle. I think it's pretty important right now that we look at that as a foundational capability from the start of each effort.
Certainly. Hugo, tell me what you think the major limitations of AI are today, and how we might be able to get beyond that.
So I think Eileen is really kind of raising some of the key points. The ethics of AI, the fairness of AI are all really fundamentally important, and that we need to kind of spend more effort to understand that. One thing that we've been doing to help in that regard is to come up with AI where you have enough information, enough transparency as to what has the system really learned, right? So what is the, in terms of, can you represent in some meaningful way what they call the inductive bias? Like when you get a new result or you generalize, why is it, what's the basis for saying that you can generalize to new data? What's the, that helps you to kind of understand fairness. It helps you to understand many of the core issues that we're seeing right now. And we believe that to really have good transparency, explainability of AI, it's time to start building upon the correlational models that we get with a lot of the current algorithms, machine learning, deep learning, as Eileen was pointing out, to move beyond that with more symbolic AI and graph kinds of processes and prior knowledge and all of that. And then when you combine the two together, now you have a more principled approach to say, for any model, basically, it's not really acceptable for the model to just tell you, here's the answer, or here's our result. And really, you need to always understand, why is that result happening? And so with regards to the limitations, I think there's been some great academic research, the underspecification of MLDL and modern AI today, a paper that Google recently wrote in November, that really covers, how do you, test your models and your data to understand what is the inductive bias, what is the real accuracy of the real uncertainty. So there's a lot of research now with deep learning and Bayesian methods, to basically understand what is the model, what's the real uncertainty, what has it really learned, what's the basis for generalizing, and to explain any decision that comes out of that. So we're really focused on all of those things. I think those are very important.
That's a great point. Thanks for that, Hugo. So as we close out today, I'd like to talk about the workforce and the skills and how the DoD will be able to build the acumen in its workforce to become AI ready and to be able to really pervasively adopt AI at the levels it's needed. So Hugo, let's go back to you on that, and then we'll pass it to Eileen to close out.
So I think that I can't really speak for the DoD, but for Cisco, I could tell you that it is getting it's difficult to find people that can you have data scientists, and to build that knowledge in the workforce is something that we're really doing a lot of training, and we feel that a lot of engineering majors in general, and with mathematical background, and even software engineering and many different area fields, that the future workforce can become quite effective in learning the new techniques. And if you apply some of the new developments where you have AI on AI, basically AI that's assisting you to develop AI models, this makes it so that much of the engineering and technical aspects of the models can be automated, empowering your workforce. But I think everybody, almost every person now in the company and probably in the DoD has to become aware of data, the ethical issues, some idea of what AI is and how it can be useful, because we're just touching upon the tremendous opportunity that AI has for the DoD and for enterprises.
Yeah, I think you're right. It's got to become part of everyone's job. Eileen, what are your thoughts on this?
Well, I agree. It's really it's part of everybody's core DNA as they're moving forward. And so for us, we're looking at the digital data natives that we're bringing into our department, both for our enlisted military workforce and as our military at the Air Force Academy. So we're trying to be deliberate and intentional. Just this year, our Air Force Academy is offering majors and minors in data science. Those cadets, when they commission, will go into every mission area. So that will create capability, not just in the emerging tech data science field, but across all of the mission areas, which I think is really important. We also have an emerging and growing data science intern program as a feeder program. But once we get great individuals into our department, we need to continue to invest in them. They're our most precious resource. And so it's really about having multiple tracks to encourage and reinforce those learning opportunities. So whether it's high quality, just-in-time online content through Digital University, whether it's a graduate degree program or certificate program through our Air Force Institute of Technology, whether it's face-to-face or online, whether it's short courses or longer courses, or whether it's just active learning where we spin up a problem set in a datathon and just crowdsource solutions. It's really about giving and building that talent at every level, operational, tactical, strategic. And really investing the right tools with the right capabilities so that it's that lifelong learning process, because this is an emerging field. It's always going to be emerging tech. And so we have to set up that environment that is persistent in giving them multiple opportunities, different learning paths, so that they can continue to invest in themselves. And I think that's what's really exciting, is because this particular field, it's constantly changing in a great way that's bringing new capability, makes it exciting for people to want to not just start a area, but flourish, continue for a true career path moving forward. It's pretty exciting.
It absolutely is exciting. And it's been exciting to hear from both of you about this emerging field. And I look forward to hearing more about it in the future. But for now, that's all we have. But thank you both so much, Eileen Vidrine, Hugo Latapie, for your time. It's been a pleasure chatting with you.
Thank you very much.
Thank you very much. Have a great day.